Okay, still in topic C. Now that we've used all these models and number lines to help us understand, we are going to work really hard on just being able to do it numerically, using an algorithm, using lots of different ways, any way that can help us get to the right answer now that we really understand what we're doing when we add or subtract. So we are going to be solving them by finding common denominators, and this is where we really introduce and strengthen the idea of a lowest common denominator, something you probably learned in school, often abbreviated the LCD, lowest common denominator. So we will encourage kids to write fractions vertically like this so that they can rename the denominators with a lowest common denominator. In this case, 20. 4 is a factor of 20 and so is 5. And then we look for the clue of what do we have to multiply 5 by to get 20? And that would be 4. And so we must do that to the numerator so that we are really multiplying by 4/4, which is 1. We call it the giant 1. Sometimes we even draw a 1 around it like that to help kids really see that they're just multiplying it by 1. And when you multiply by 1, you don't change the value of a fraction. All we're doing is renaming it into a denominator that works for both of them. So this would be 1 times 4, that would be 4/20. And this we're multiplying by 5 to get 15/20. And then we can easily add them and get 19/20. At the same time, we're helping kids to always think about simplifying. So here's a problem, same kind of thing. Again, we're looking for the lowest common denominator. Often kids at this stage, they're nervous about this and they just quickly go, oh, I'm just going to multiply the two denominators, 9 times 6, and get 54. I'm sure that'll be a common denominator. And they're right. The problem is if you do that, you're going to have to do a lot of extra work at the end that you don't need to do if you think a little bit up front. Because there is a smaller number in value that both 9 and 6 are factors of, and that would be 18. So rather than use 54, I'm going to use 18 as my common denominator. It'll save me time later. And I got to multiply this by 3, and I multiply this by 2, giving me 10 and 15/18. And when I add those two together, I get 25/18. And as we talked about before in topic B, that is a fraction that is greater than 1. And I cannot leave that as a final sum. I must simplify that into 18/18 plus 7/18, or 1 and 7/18. We're also going to be adding mixed numbers in that same way. Still writing it vertically. Again, modeling that same thing we do when we add whole numbers. We write them vertically like this because it makes it easier to add them in columns. So again, we're going to find a common denominator, and the lowest common denominator here would be 10. We're multiplying by 5, multiplying by 2, and 8/10 plus 5/10 is 13/10. 2 plus 1 is 3. And again, I want to look at that answer and I want to say, oh, that's a fraction that's greater than 1. I have to pull 1 out of that. I have to take the 10/10 out of that and give it to the 3, making that 4, and leaving me with 3 more tenths left over, because 13/10 is 10/10 plus 3/10. So I'm giving the 1 to the whole number here, making it 4, and I got that leftover 3/10 here. This is the simplified version of that answer. Okay, and also, just like with whole numbers, we don't just need to add them, we need to be able to subtract them as well. So we're going to do the same thing we were doing with adding, only we're going to subtract. And we really want kids to pay attention to the signs. They often get problems wrong on tests or on exit tickets in class because they're not looking at the signs. So I would encourage you to help your children to always make sure that they pay attention to what it says, maybe even say the problem in their head. 4/5 minus 1/3. It'll help them to connect to what the signs say. So again, we're writing them vertically just like we would any subtraction problem that we didn't know the answer to in our heads. And we would find a common denominator. And 3 times 5 makes 15, so that would be 5/15. Times 3 would be 12/15. And 12/15 minus 5/15 is 7/15. Nothing to simplify there because nothing divides into 7 and 15 equally. It's already in its simplified form. In this problem, we've got mixed numbers that we want to subtract. The same thing holds true, just like we were doing before. As long as we have like units, we can subtract them. Just like whole numbers, we want ones from ones, tens from tens. We can't subtract halves from sevenths. They're not the same unit. So we're going to make them the same unit over here. We'll use 14ths because it's a multiple of both 2 and 7. And I get 12/7 minus 12/14, sorry, minus 7/14 is 5/14. And 2 minus 1 is 1. One of the big mistakes kids make at this point is they forget to subtract the whole numbers. They do the fractions perfectly and they forget the whole numbers. So encourage your kids to really make sure that they always look at everything that they've done to make sure they've subtracted everything that they should. Again, no need to simplify that because there is no number that divides into 5 and 14 equally, so that's already in simplest form. Finally, we get to a problem, as we do in whole numbers, where we have to borrow, where we don't have enough ones or we don't have enough tens to subtract, so we have to borrow from the next place. Here is a problem like that using mixed numbers. Again, I'm going to look for a common denominator. Here's another one of those problems where many students are using a denominator of 48, which is not wrong, but it'll make extra steps at the end where you've got to simplify. Instead, I'm going to use 24 because it's the lowest number that both 8 and 6 go into. And when I multiply by 3, I get 15 here. And when I multiply by 4, I get 4 here. And now when I go to subtract, I've got a problem. 4/24 minus 15/24. I can't take 15 away from 4 unless I go into negative integers, which actually is true, but it's complicated to explain to the students. For now, we just want to say it can't be done and get a positive result. So, just like with whole numbers, we borrow. And the place we borrow from is from the whole numbers. So I can take 1 away from the 3, leaving me 2 left. And for the 1, I get a fraction equivalent to 1. And since I'm using 24ths, I'm going to give myself 24/24 because that's equal to 1. So I took away 1 here, I gave myself back that same 1 here. I haven't changed the value, it's the same. Now the total of this here is 28/24, which I can then use to subtract the 15/24, leaving me 13/24, and 2 minus 1 is 1. There's a lot of steps to it, but it's the same work that they've done since 2nd grade, renaming numbers and borrowing from larger units so that they'd have enough of a smaller unit to subtract.